we are going to see polynomial regression. So polynomial regression is very straightforward. So I am explaining you step by step approach why polynomial regression is important and why we are doing that, which problem polynomial regression solve. So for doing that, let's see first of all our data. Our data is like contain some column and which contain temperature and ice cream sales units, and temperature is in the Celsius. So let me see the shape of this data. So you can see that we have 49 rows, 2 columns. So let's first see what is the data look like in the graphical representation. So for that I am just importing some libraries. So importing the NumPy library as np, then I am going to import matplotlib.pyplot as plt, and then we are going to add one line which is required in our matplotlib library, matplotlib inline. Once we imported successfully these libraries, actually I already imported the pandas library, so we no need of pandas anymore. So now, so why I am explaining this step by step approach, or why I am doing the hands-on right now on the live session, because in the live, when we are doing the hands-on practice, so at that time we face some errors, some difficulties, and we solve that. In that way we learn very much instead of just explaining the one by one slide to you. So that's why I am doing the hands-on practice, so you can see or you can learn why I am doing the hands-on practice at that time. So also, so let me, so I am successfully imported that file, that libraries which are required for us. So now we just see the graphical representation of the data. So for that we can use scatter plot, we can use df of temperature, comma, my data frame of the ice cream. So let me copy this. So you can see that my data frame, let me do the plt.show as well. I am doing plt.show because when I am doing that, so it's printing the class name or the object here as well, object definition. So if you do the plt.show or matplotlib.show, then it will remove that warning. So in that way our view is more genuine or more accurate or more visible or user friendly, we can say. So now you can see that I have like curved like structure. This is not a straight line. So that's why that's why actually our polynomial regression came into the picture, because this problem regression will not solve. Regression will solve only the straight line problems. If my lines is go this, then regression will solve that. But this is the curve like structure or the bell curve, opposite direction bell curve like structure. So this problem will not solve by the regression, straight line or simple linear regression or the multiple linear regression. This need to be solved by the other way. So polynomial regression give us the more extra benefits in the over the linear regression. So that's why polynomial came into the picture. So now we can see that now our data is visible and we can see that okay, polynomial regression is applicable that. So now we are going to implement that. So first of all we can do, we need to do that, like we need to split the data into training and testing set. So for doing that we need to import some libraries in the sklearn. So for that let me go to the Google and use here train test sklearn. So here you can see here our first line is showing that our documentation like train test split. This is the function we are using in the any machine learning libraries. So for splitting the data into two phases, training set and the testing set. So here if I go to my file, I just put here, I use from sklearn, and then I am going to like train test split. So this will by my function will imported successfully. Other than that we need some function like from sklearn dot preprocessing import polynomial feature. Also from sklearn dot let me import the linear regression function. So for that I didn't remember that the exact what is the class name for the linear regression. So for that I can do just Google it, because sklearn is very friendly for us. So we just do linear regression in sklearn. We just type here, we have the first link, we just open it, and you can see that here we can see that okay, sklearn should be belong to the sklearn linear model class. So what we can do here, we just have to use linear model. So I forgot that, and you also no need to like remembering everything, because always we have the internet and we have the documents hands-on and accessible to the internet in a free of cost. So we can easily go to the internet and get the all the class name from there, because remembering everything one by one line, it's very difficult, and when you are doing practice a lot, you will automatically remember that. So we need that as well. So I'm just importing that. So yes, so now our all the modules are imported successfully. If we need many modules or future modules, we can import it in our later stage, but right now this is the enough for us. So let me split our data to training and testing phase. So for that we need to use x hyphen train comma, I use underscore here, and x hyphen train test space y underscore train comma y underscore test equal to, we can use this function. Here we are passing just like what is our x parameter. Our x parameter is temperature, right? And then we are passing our y parameter. So df of y. So I'm just copy pasting thing to save our time. So here we can say okay, this now you can see my training and testing data is split successfully. If I do here like this one, and I use shape for auth, and I am just printing the shape, so we can see that what the data look like. So you can see there I have 36 rows in my training and one column. It's here, it's not presenting anymore, because we just have to here add or create the two-dimensional array instead of one-dimensional array. So I'm just creating that. So I'm just adding the parenthesis here. So you can see that now I have 36 rows, one column, 13 rows, one column in my test, and training has the 36 rows and test has the 13 rows. So now my data is split, but here if I want to split the data based on the size, or I want to just change the size of training set and testing set, you can use test size attribute. So test size attribute is 0.1, means if I have 100 rows, then my 90 rows belong to the train and my 10 rows belong to the test. If I put here 0.2, then my 80 rows belong to the train and my 20 rows belong to the test. So I am putting here like 0.1, and then I am putting like it's changing the all the shapes. So I have 44 rows and 5 columns. Total I have 49 rows in my data set. So it's splitting based on that calculation. Mathematical calculation is taken care by the sklearn, so we no need to worry on that. So I am just explaining or going the hand by hand practice, because I always know like hands-on practice is always easy and always helpful for us in the future scope. If you face some problem, so at the time you will know, okay, this problem will already I face that and I know how to solve that, then I can solve it right now as well. So that's why I am explaining you one by one and hands-on practice. So now you can see that my testing and training data set is ready. So what we can do, we need to like initialize the polynomial feature class. So we can say poly feature equal to, I am just initializing this class. Yes, I initialized successfully. So now we can see that we can have some attribute for this column. So degree equal to 2. So degree equal to 2 use for the making sure that what is the degree of the my attribute or my x attribute, means my features. So I am setting here the degree equal to 2. So why degree here and what degree here, you can put the message in the comment. Based on that I will create the another video which will explain you what is the degree and why a degree is required. So I am using here 2, not a 32. So polynomial feature is successfully initialization. So initialize successfully. So now we can initialize the linear regression class. So for that we can use regression equal to linear regression and just doing like that. So here I need to pass here like parameters, training parameters, but we can't pass this x train and x test directly, because then it's become the linear regression. But I want to convert this to the polynomial regression. So for that, how we can convert that? So here I just put get x train, then y train. So it will become the linear regression model. But I don't want to do that. So I'm just doing here like regression dot fit method. It's used for that. So if I transfer that, then you can see that my regression will become the linear regression. I just use the coefficient and I will just use the regression dot intercept. So it's become the linear regression right now, means it become the straight line. But I want to make sure my line is something like that, this curve like structure. So how we can do that? We can do that using the polynomial regression. So for that, what we can do, we need to transfer this, or we need to change this x parameter. Y is not applicable, or polynomial regression, in terms of polynomial regression, our output or target variable is not applicable. Polynomial regression is not applicable on the target variable, it's applicable on the input variable. So my x is input here, so I'm just changing that. So how we can change that? We use the poly feature here dot fit transform method, and then I am passing the x term. Now it become our polynomial regression. You can see that coefficient there at the type there was one coefficient, but right now here you can see that 3 coefficients. So why these 3? Because it has the method, or it has the formula which contain like, it has like very deep understanding we require for that. It's take lots of time for explaining that. You can put the comment below, I will explain in my future video based on that comment. But for now, just mention or just remember that this is the way you can fit, or you can change, or you can apply the polynomial regression. If I got the 2 or 3 comments, then still I will create the video and put it in my future list. So my coefficient is changed and my intercept will be also changed. So now my data is polynomial regression, means my curve is something like that, right? So now we can predict our output using the regression, because in the polynomial regression, at the end of these things we are using the linear regression, or we are using the simple regression. But for that we need to change, because here you can see that this is also the line, right? The straight line, or this is also the line. But right now what I am doing, that instead of doing the straight line, I am just changing the line behavior like this, like curve structure based on our data. So I am just training this page and saying that okay, line should not be the straight line, it should be the curve structure line. So now we can predict that. So we can use a regression dot predict method. So what we want to predict? We want to predict the x test. But if I pass the x test directly to my regression predict method, then this will become the applicable for the predicting the values for the straight. So we need to change this x test variable as well, and apply the polynomial method to the x test as well, just like we apply for the x test. So what we do for that, how we can do that? So we just use this poly feature dot, so I'm just okay, poly feature dot fit transform, and then we can use x test. Now my data learned successfully from that curve structure. So here we can say y underscore predict equal to, okay, I'm just putting the value inside that, so we can easily accessible that. So y predict, okay, my prediction is done, right, based on that x test value. So I need to check that what is the is my prediction right or wrong. So how we can do that? We need to import something for that from sklearn dot we can say matrix. From matrix class we need to import mean square method. Okay, this one. So here for the mean square method we need to pass what is the actual output, what is the true y. So true y is our y underscore test, and comma I am passing it's a predicted y. So it will checking that okay, my true y, what is the difference between my true actual output and my predicted output. So it is giving my like 9 is my the difference between my actual one and predicted one, which is like very good, because our mean square error should be the 0. That's the our ideal condition, but mean should be never 0. Mean should be the 0, then it will become the problem of overfitting. But right now I have some errors. It's not like 100 or like 50 or something like that. It's just a 9, which is like close to the 0. 1 2 3 4 5 6 9. So it's close to the 0. So we can accept this error. And now see how the graphs look like if we use or if we put this in the graphical way. So for that I'm just using this one as well. I'm just copy pasting this one to save our time. So here we can see that we need to pass here what is the x test, and I am going to pass here y test, and I am just printing the graph. So graph is like this one, like this direction, because it's take only 4 to 5 row. If I change here or if I put the data size, it's around 0.38 something like that, and I run all the things, then you can see actual difference here. Now you can see that actual difference or actual y. Actual my predicted is training set is like this, or my actual set is this, and inside that I have few training sets which is like this. So now you can see that my data is increases, so that's why my actual error is also increases, because if my data is increases, my mistake performing on data it also increases. So that's the become increases of the mean square error. So now we can plot the plt. I use the plot method here. So I use x test comma y underscore predict. Okay, it's showing the weird behavior, but I know how we can solve that. So we use r plus. Now you can see that my testing variable or testing data have some points. Blue points is represent as a testing data and plus is represent as a predicted data. So you can see that my prediction is not much far away from my actual one. It's close to my actual one, but not exact, because if it's become the exact, it's contain the problem of overfitting. But right now it's not exact. It's like it's away, or it's like away from that actual one. So we can say that it's a good fitting the problem, or it's a good representation of the polynomial regression. So if I want to sum up this in one line, I will say, so we are predicting something based on the not a straight line, because linear regression will fail if our data is not a straight line data. Then polynomials is come in terms of the solving the problem or adding the more extra feature in the linear regression. So how we can implement the polynomial representation? We just need to fine tune the data and saying that I have the line, but my line is not a straight line. My line is a different line. So we need to import, or we need to fine tune my input variable, and based on that my model will learn, and my model will pass this data to the linear regression, and linear regression will predict my output. So this is the actual way to predict or implement the polynomial representation in our data. So I am explaining one by one how we can do that. You can also try it from yourself. You can took any data source from the Kaggle and again apply this technique to that data, and then you can be the you can be the get the hands-on practice how we can do that after this as well. So this is my explanation around that. So you can see that also we miss one thing, is that we didn't check the null values in our data. So how we can check the null values and how we can treat the null values, I have created one video for that. You can check that and you can view around that. But I know this data does not contain any null values, so we are good at that time. So thank you so much for watching this video. Thank you.